Good morning and happy Monday. Today is May the 4th, so may the 4th be with you. Anyway, so whatever. In any event, today we are going to talk about section 12.5, which is talking about the relationship between gravity and distance, which is, of course, governed by what we call the inverse square law. And what it says is that the force of gravity is reduced over a distance by a factor that is the inverse square of that distance, meaning that if we examine Newton's universal gravitational law, we get this. Now, I'm going to cut the masses out and not talk about them at all, but what we end up with is this relationship where, remember, G is Newton's universal gravitational constant. And the inverse square is 1 over the distance squared, or r squared in this case. So the force of gravity is reduced over a distance by a factor that is the inverse square of that distance. So let's have a look at this. Let's say this represents a distance that we'll call r. I know the r is a little bit blurry here, but if the distance is 1, well, what's 1 squared? Well, let's imagine for the sake of argument that g is 1, and 1 over 1 squared gives me a force of 1, okay? If I then double that distance from here to here, and now the distance is 2r, well, what's 2r times 2r? It's 4r squared. I'm sorry, it's 2r squared, which is 4r, yeah, 4r squared in the end. And so 1 over 4r squared, I've now cut the force by a quarter. All right, 1/4 is the inverse square of 2. So if I double the distance, I cut the force by a quarter. Now what happens if I triple the distance? Well, if the distance is now 3 times as long, all right, I plug in 3r here, all right, so this is 1 over 2r squared. This is 1 over 3r squared. And what I get here is 9r squared. And so 1 over the 9 is 1/9, and that is the inverse square of 3. Now, pictorially, if you look at this, oh, for the love of God, pictorially, if you look at this, you'll see that if we start at this point here, this has an area of 1 square. All right, so the distance is 1. We got, I don't know what's going on with my mouse today. If we go to this distance, notice that it's 4 squares, right? And it's twice the distance. And then if we look at this one, it's a grand total of 9 squares at 3 times the distance. And so that's the relationship. The force, let's say, is being spread out over 4 squares or over 9 squares. And so that's essentially what the inverse square law says. So as you get further and further away from an object, the force of gravity gets smaller by a factor that is the inverse square of the distance. Okay. Now, that brings us to example number 3. And this example says, suppose that an apple at the top of a tree is pulled by Earth gravity with a force of 1 Newton. If the tree were twice as tall, would the force of gravity on the apple be only 1/4 as strong? Now, that's an interesting question, because based on what I just told you, you would say, yeah, it must be. But what you have to think of is that the center of gravity of the apple is, in the middle of the apple somewhere. The center of gravity of the Earth is something like 3,000 kilometers from here. And so going to the height of a tree even doubling the height of a tree is not going to significantly change the distance between the center of gravity of the apple and the center of gravity of the earth. And so therefore, the answer is no. Okay, a twice as tall apple tree is not twice as far from the Earth's center. All right, the taller tree would have to have a radius that was equal to the radius of the Earth, a height rather equal to the radius of the Earth, in order for the weight of the apple to be reduced to 1/4 of what it is at the original position. All right, so that is the deal. All right. So, gentlemen, today is Monday the 4th. On Wednesday, May the 6th, so 2 days from now, I'm going to ask you to take a quiz on Chapter 12, Universal Gravitation. This quiz will cover all of Chapter 12, and in order to review for it, for tonight, I would like you to do the review questions at the end of Chapter 12, numbers 1 through 10. Okay? So, again, I'll write that in the topics, and I will include a sheet of paper to just for any of you who don't have your textbooks. All right. So, happy Monday, and I will see you tomorrow.